And welcome back. We are now going to review a very key topic that we had talked about in our previous course, which was that of inheritance and polymorphism. So the big thing that we had to remember with inheritance and polymorphism is it was this concept of derived classes. And with derived classes, Java uses them in a very simple structure. There's a base class, and then you have the derived classes. You, of course, sometimes also hear different terminologies, such as like subclass or superclass. But ultimately what we need to know is that derived classes, which are not the base class, they are the classes that are going to inherit all the methods that the base class has. Now, derived classes are indicated using the extends keyword. And that's the key way for us to know like which one's a base class, which one's a derived class. It is an extends. Now remember, you can also, of course, extend another derived class from a derived class. So derived classes can also give way to more derived classes. Now, the big thing to remember is that derived classes can use the superconstructor to inherit constructor parameters from the base class itself. So if you recall, we had this employee class, and we say public hourly employee string the name, date the date, double the wage, double the hours. And then if you notice, we have a super invocation that says the name, the date, which means then we can actually just inherit from the previous class those parameters. We don't need to necessarily reset them up because, again, those are inherited for us from the parent class. Now, another concept that we really kind of touched on was this idea of late binding. Now, with late binding, this is a thing that Java uses pretty much where it says, hey, we got a method definition, and we're going to associate it with the invocation, but this is only going to happen when the method is invoked at runtime. So it has to first invoke it first. It doesn't do early binding, which some programming languages will do. It does late binding. It's something that we're already very familiar with how Java functions and how it uses it, but it's just a more formal term that we just had to be familiar with. Now, one thing that we did get out of this was the ability to mark a method as final if we want to indicate that the method cannot be overridden with a new definition in a derived class. And so that is, of course, our key thing here is if we create a derived class, let's say, and we have another derived class from it, and I say, you know what, I don't want this new derived class to be able to change what this method does, I can go ahead and mark it as final, and it will remain that way. Now, there were some methods that were very important to us, which were the equals and toString methods, and the ability to recognize that everything is part of this object class being pretty much the super class of all classes within Java. Now, those two methods, equals and toString, they're very most important because they're pretty much almost always going to be in every class. And equals, of course, is going to compare one object to another and just test for equality. It's a very common thing to do. And of course, toString, which allows us to actually write out the different values, the different variables that would have be contained within different objects. Now, with derived classes, sometimes we do have to modify these methods a little bit to fit the new classes. So, for example, if we have a derived class, it may have new variables that didn't exist within the base class, and so we have to go say, hey, we got a toString method that exists in our base class, but I need to override it for this derived class so that way I can include those new parameters. Now, ultimately, all this, the way this functions, again, is because of the object class, and the object class has methods. Well, what are those methods? The main methods from the object class are the equals and the toString method. And because those are from that object class and all classes are derived of the object type, therefore, they all need to pretty much have a equals and toString. Otherwise, it's just going to default to whatever the equals and toString methods are inside of that object class. All right, and so now let's go over to Eclipse and just take a look at some code here and really kind of take a good idea of how this implementation works. So I'm going to have some previous programs that we have done here. And so you'll probably recognize the date, the employee, the salaried employee, and hourly employee classes. And what I've done is I've gone ahead and created an hourly employee. We have Joe here, and we set him up using the parameters of the hourly employee class. If we go and review that and look at the constructor here, we have a public hourly employee, string the name, the date, double the wage, double the hours. And of course, we have a super invocation right here. Now, if I don't have these pieces in here, if I take these out of here, all right, you notice it does not like the name and date just on its own. It's like, I don't know what these are. It's because you need those parameters in there still, because it's going to ultimately pull these from the employee object. So it's going to treat these here. So here's our private string name, private date, hire date. But if you look here at the hourly employee, these pieces here don't exist. Like string the name doesn't exist as a variable here. And so that's why these are going to be super invocated from here. So here's a string object right here that it's recognizing is from this super call right here. Then if we look, we of course just have some methods that we're using. We're using a get name method, so a nice little accessor right there. And it of course says it's going to change the name. And then all that simply does is it does a set name, which is just a mutator. And then we just print it back out. And we invoke another method here just to check the pay. Then just for kicks, let's do a salaried employee. And of course, salaried employee is another derived class again. Both of these classes that we're looking at are extending employee. And notice employee does not have the extends keyword. And so this one, of course, is following its constructor right here. So we have a string, a date, and a double. And so when we look at this one here inside of our inheritance demo, we can see we have a string, we have a date, and we have a value. All right. And so if we go ahead and give this program a run, you can see that it will return Joe Worker because, of course, this is the get name right here. We have the changing of the name because that is the name that we are setting it to. And we have the new record right here. Sorry, this is printing out the entire Joe record right here. And then we, of course, also printed out his pay here as well. So that was the get pay. And then we have, last but not least, the pay here for Sam. We've noticed there is nothing else to kind of really recognize out anything for Sam here. But there, of course, in here for us to be able to have as information. So if I wanted to do one more thing, let's say I wanted to print out Sam's information. System.out.println, and we just say Sam. Notice I don't need to go through and do each individual thing, because remember with Sam, this is saying effectively do a toString. So if I look at salaried and do a toString, it's going to call get name, a get hire date.toString, and it's going to print out the salary per year. So if I rerun my program, you can see now it will print out, there's her name, and there is her salary information. Inheritance, of course, big thing is using the derived classes and be able to use like super invocation, and polymorphism just extending to how we handle those different objects within inside those classes.